Okay. All right, so x minus 5 here cannot equal 0. So x minus 5 cannot equal 0. So x cannot equal 5. That is your domain. Now, it could be written two ways. It may just be written as x cannot equal 5. Or it might say all values except x cannot equal 5. It might be written that way. Or it might be written like this, negative infinity to 5, and then 5 to infinity. So that includes everything but 5. There. You could see either one of those on multiple choice. Okay, we're going to do the domain for all of these, and then we're going to go back and look at range. So if I'm looking at domain for 9, I really don't care about whether I have an asymptote or a hole in the graph. I would just look at the denominator, and I see x cannot equal 3, because x minus 3 cannot equal 0, and x cannot equal negative 2. Now, if we go back to what we were learning yesterday, one of those is a vertical asymptote, the other one is a hole in the graph. Which one would be the hole? It's the negative 2, because that x plus 2 is in the top and the bottom, right? It would cancel out. So that makes it a hole in the graph. If you graph this, you're not going to see any issue at negative 2 unless you drag your cursor over there. So our domain would just be x cannot equal 3 and x cannot equal negative 2. So it's every number except for those two numbers. Or it might be written like this, negative infinity to negative 2, negative 2 to 3, and 3 to infinity. All with parentheses, because those parentheses mean we don't include those values. Okay, for 10, William, what value would give me a 0 in the denominator there? 2. So my domain for that one would just be x cannot equal 2. Or if it's written the other way, negative infinity to 2 up to infinity. That means all the numbers from negative infinity up to 2 don't include 2, and then 2 to infinity, again, don't include 2. So I like the x does not equal. It's easier on this one.
So do we have to do the infinity?
It's just you may see it either way because there'll be multiple choice. So you might see some where it's written like this, but you could also see some where it's written like this. So it won't give you both at the same time. Okay? How about 11?
X cannot equal negative 2.
It's not negative 2. It's not negative 3.
Positive 5.
It's not positive 5. It's not a whole number. So what can we not have? We cannot have a 0 where? Almost 3 over 2. Nope. All right. So the bottom, 2x. So y'all are just guessing. Let's think about how to get this. What'd you get? That is correct. All right. So 2x plus 3 cannot equal 0. Whatever's in the bottom cannot equal 0, right? And then we just solve that simple equation. So we would subtract our 3. So we got 2x cannot equal negative 3. And then we divide by 2. So x cannot equal negative 3 over 2. That is our domain. It might be written like this. It might be negative infinity to negative 3/2 and negative 3/2 to infinity. Okay, so for these, So let's summarize up here. For domain, what are we looking at? How do we find the domain? What can we not have? 0 where? Denominator, the bottom of the fraction. So the denominator of the fraction cannot equal 0. So we just figure out the numbers that would make the bottom 0. We don't really care about the top at all for finding that domain. To me, it is easier to find this from the equation than it is from the graph. Okay? Because vertical asymptotes are easy to see on the graph, but holes are not easy to see on the graph, and you will miss the holes in the graph a lot of times. So I think it is easier to do these from the equation. Range, however, there are ways to do it without there are ways to do range without the calculator, but I do not think it is easier, and I don't want to spend time doing that. So if we go back and do range for this, if we type in f of x equals 1 over x minus 5. So whenever we are doing range, I'm going to do this. I'm going to do y equals 1. All right, and then enter, so that'll slide. All right, so remember, whenever we did range, we were starting at the bottom and working our way up to see if there were any numbers where our function was not defined. What you're looking for here is the horizontal asymptote. That's going to be the place where we don't have any numbers. So if I take this and move it up, ignore that, so it's out of the way. If I move this up right there at the x-axis, do I touch this graph, the red graph, at all? I do not. If you zoom out, it's going to look like it eventually touches, but is it really touching? It is not, because that's a horizontal asymptote. And if we zoom in enough, there's a little bit of space between it. This has a horizontal asymptote at 0. So for our range, if we go over here and add our range to this, range is y values. So we say y cannot equal 0. Or you may see negative infinity to 0 and 0 to infinity for that. We okay here? All right, on 9, if we type it in, we have y equals x plus 2 over x minus 3, x plus 2. Here's what I'm talking about domain being tricky. I can see a vertical asymptote at 3. I know there's a discontinuity there, so I can't have that. Where's the other number we can't have equal to? It was negative 2. Does it look like there's a problem at negative 2 on this graph? It does not. But if you drag that right there, there's a hole in the graph. But they're hard to find, so that's why it's easier to look at the equation. So, but we're not talking about that. We're talking about this horizontal asymptote. That one right there, oh, I can't get it. There we go. Is also the x-axis, right? We have a horizontal asymptote there. So this one is just going to be the same. I'm just going to write same as that one. Same. You just can't have y equal to 0. We're okay here. All right, let's try number 10. 10 x to the second plus 3x plus 2. And then on the bottom we got x minus 2. Now, this one's weird. I do look like, oh, are you going to see one like this? I don't know if you'll see one. Okay. Yeah, okay, this one is weird. So it looks like we got a big gap in the middle of this, right? We've got this point right here is like my highest point, and then I don't have anything in the middle, and then it jumps up to this other point right here. So if I look at that highest point right there, if I zoom in a little bit, this like maximum point right there, its y value is 0.072, right? So I'm going to do the range this way for this. We go from negative infinity up to 0.072. But then we have a big gap, and we don't have anything in the middle here. And we're going to go to this point right here, which is the lowest point of the other part of the graph, right? We're doing y values because this is range, so that's 13.928 right there. So we would go from 13.928 up to infinity for that one. This has a special type of asymptote. It's called like a slant asymptote there. And the only time this is going to happen is when you're like your degree on the top, which here we got x squared, is 1 greater than the degree on the bottom, which is x to the first power. So if I had like x to the third on the top and x squared on the bottom, you'd have something that looks like this. So this will only happen on like a special type of equation. Most of the other ones here are just going to be y does not equal something for that. All right, and then we've got one more to look at. We've got f of x equals x minus 5 over 2x plus 3. And this one looks like it has a horizontal asymptote. It is not at 0 this time because that actually crosses the graph right there. If we go up, it doesn't look like it's at 1 either. That crosses. Maybe it's halfway between. And it looks like that probably works right there. So you may have to, hopefully that'll be multiple choice, so you'll have some options to test so you can kind of look at it, because it's a little hard to tell without knowing some calculus how to find that the other way. So my range here would be y cannot equal 1/2 or 0.5. Or it might be written like this, negative infinity to 1/2. And then 1/2 to infinity. There. So for domain, we're looking at the denominator cannot equal 0. For the range, we're going to look at the graph and see. For the most part, you might want to add that in. Range, we're doing that from the graph. And y cannot equal the horizontal asymptote. On most problems, there are some, like number 10, that are a little bit weird that you're just going to have to look at the graph on. Okay, questions there? All right, we are going to shift gears to solving. So we are not going to have a specific homework for that section. We will look at it some on our review tomorrow. So these copied a little bit weird, but if you keep it more regular, that's the problem. That is not the case on these notes. It really shouldn't get any more difficult than this particular problem. There'll be some that'll be a little bit easier. So, of course, we always want to know how could I do this on Desmos, because that helps us check our answer. So, if I pull up Desmos here, all right, and I want everybody to type this in with me as we go here. Oh, wait, I've got Desmos already open. Let's get rid of that one. All right, so, well, hold on. I need to go back. What happened here? Oh, that, and close that. Let's see. Where do I have that? Let's make that full screen again. Okay. Let me pull up. Okay, let's make this over here. All right, so I want everybody to do this with me to make sure you know how to do this, because if you don't know how to solve these equations, you can at least do some of them on Desmos, all right? So this is the same for all functions that you're going to do, right? Any equation that you're going to solve, whether it has fractions or not, you can put the left side of the equation in the first line. So you're going to do y equals 13 over 3x minus 3 minus 1 over x minus 1. Okay, it'll graph something. That's the left side. You can type in y equals x over 9 on the other side. And then you are looking for where those two functions cross. And it happens right here at -5. We really only need the x value because we're solving for x, right? And then over here at +6, which are our two answers that we got.
I just typed in the equation.
If you do that, if you just type in the equation, it is going to give you vertical lines at those points. It will work well if they cross at whole numbers, which a lot of these are going to be whole numbers, so it's going to work. But like, let's say that was a 7 right there instead of a 9, right? So if that was a 7, then it won't let you find like what that value is. So if it ends up being a fraction or a decimal, it makes it where you can't really solve the problem. So I would prefer you to do it the way that I did, because if it's a fraction or a decimal, it will not let you do that. It will work as long as it's whole numbers, though. There, it's just going to put like two vertical lines where you have those answers at. But if you do this, like if I go here and I change that 9 to a 7 here, now I can go here, well, the answer, if that was a 7 instead, is -4.356. So you can find the exact answer if you do it this way, even if it's a decimal or a fraction there. So that's why this is a little bit better than doing it the other way, but most of the time, just typing the equation will work. Just sometimes it's a little difficult there. And if you have multiple choice answer choices, you can probably narrow it down, even if it is fractions. If it's a type-in box, you'll need to know the exact number. Okay? All right, let's go to the next one. Okay, so I said I started with probably one of the more difficult problems you're going to see. 2 is not as bad. Okay? So, for number 2, this fraction has an x minus 6. This fraction just has an x. What would my least common denominator be for that? Okay, so if I'm going to use x minus 6, can I do minus 6 on top and minus 6 on bottom? Is that okay? Like if I have 1/2, if I subtract 6 from the top and subtract 6 from the bottom, I get -5 over -4. Is that equal to 1/2? -5 over -4? No. It changes you cannot add or subtract to the bottom. So x minus 6 is part of what we need, but it is not the only thing we need. So when you have something like this where you have x's, your least common denominator here is going to be x times x minus 6. You just multiply the two things together. Okay? So, I need both of those denominators to be x times x minus 6. So, over here, Marley, what am I missing on this first denominator? I need an x, so I'm going to put an x there. If I put an x in the bottom, I also have to put an x on the top. Alright? Shay, what am I missing on the second one? The whole thing, x minus 6. So I would multiply by x minus 6, and when you do that, make sure you put it in parentheses. So now I have got 7x over x times x minus 6 equals 4 times x minus 6 over x times x minus 6. Now, if I'm doing what I'm supposed to, I didn't even tell you about the excluded values on the last time. Our excluded value on the last one was, what, 1? Were our answers equal to 1? No, so our answers were fine. Most of the time, that ends up being the case. What are our excluded values here? 6, so x cannot equal 6. There's another one. And 0, because that x right there can't be 0. So, if I get 0 or 6 as an answer, I've got to throw it out. It doesn't happen a lot. I didn't go through these notes to make sure we had at least one where it happened, so it might not happen at all on the notes. I should probably add one in. I just picked problems that looked good. I didn't work all of them out for that. So, here, now the denominators are the same. When they're the same, you can mark them out. So, now we just have 7x equals... Is it okay with you guys? Can I go ahead and distribute that 4 right there? So I'll get 4x minus 6. Do I have any x squareds? I do not. So this is just a regular equation like you learned how to solve at the very beginning of Math 1. Oh, it wouldn't be a 6. Thank you. You're right. What should it be, Aiden? 24. Yeah, thank you. Much better. Yeah, 4 times x, and I should have done 4 times 6. I drew it, and I didn't do it. All right, so how do I solve this equation? How do I get the x by itself? We need that 7 and 4 to be together, but they're on opposite sides. So I need to, like, move one over to the other side. I would pick the 4x because... if you do the 7, then you end up with nothing left on the side, plus you get a negative. So this is going to be 3x equals negative 24. Okay, now we're down to one step. What do we got to do? Divide by 3, and x equals negative 8. Is that one of our excluded values? No. So this should be a good answer, right? If we go over to Desmos to check, because I want you guys on all of these. Don't call me over, when you're working on Delta Math, don't call me over to ask if it's right until you've typed it into Desmos to check, right? So we would do 7 over x minus 6 for the first one, and then we'll do 4 over x for the second one. We are looking for where they cross. We already know the answer should be negative 8. Right there, negative 8 is where they cross. The y coordinate doesn't matter because we're just solving for the x coordinate. You're talking about just typing in the equation. This is what I think Shay asked about just a minute ago. It will work. The problem with doing it that way is if you just type the equation in, it works fine as long as it's a whole number. But, like, let's say that 4 was really a 5. If it was really a 5, actually, it doesn't even work if it's 5. Let's say it's a 3. If it's a 3, I've got this number here. It might be 4.5. It might be okay, but it's not going to, like, you can't click there to see for sure. Like a vertical asymptote? Oh, okay. You want a vertical line?
Yeah,
If you do just like x equals 1, and then you can like move it left and right there. But the best thing to do for this, if you just click on one of those lines right there, either one, a gray dot is going to pop up where they cross. Because sometimes it's hard to see where they cross, but no matter what you have typed in, like even if I have like 2x minus 3 and x squared minus 4x plus 2, let me get rid of that. So like if it were a totally different thing, not even related to this, if you click on one of those, there will be gray dots where they cross. So you can. That's probably the best way to look for those. There. All right. Oops. Okay. We're gonna get our least common denominator together, and then you guys are gonna try 3. So what should the least common denominator be for number 3? 3 times parentheses x minus 2. Just the two denominators multiplied together. So I want you guys to try 3 on your own. This one's a little bit tougher. Put some parentheses around your x plus 3 right there in the top too. A little bit tougher. Might get x squared. Yeah, you want parentheses right back to those. So you're doing, like you got your x times x, and then x times x plus 3, and then negative 2 times x, and negative 2 times x plus 3. Yeah, so you'll get an x squared on this. It doesn't. You can put it on either side. It doesn't matter. Like right here, I put it on the side just because I don't like having an x in front of the 7. Because we usually look at the number first, but it technically can go either side. Yes, you want parentheses on both of those. So when you have this, it's perfect. You got to distribute here and then distribute that through. That's why it's different than last time. No. got x minus 2 times x plus 3. This is kind of the right there.
Oh, well, you guys want it all of it. It's not fun.
I'd rather do it in the morning.
You're screwed.
It's gonna be 74. Like the whole thing? Bruh.
We're not moving. You can do it now.
What?
Do it. Oh,
What did the rest do?
come back.
And then you got to do x times negative 2. So minus negative 2x.
What option are in the fight?
You go.
I didn't think that was. I feel like
It'll be negative.
I've never heard of another option.
3 times x.
Either you do it or you don't do it.
Yeah.
What?
It's either you do it.
That doesn't sound like a good crowd now. That sounds like
He had parentheses on everything.
he was ready. When you have it to sleep or you're ready.
He had his brand new running shoes on. He didn't really have.
I can't imagine.
He's ready, bro.
Everything to one side.
We're gonna get down to probably
Hey, you're not factoring this, right?
What? He said what?
Said I ain't gonna do it. I can't run it.
Why can't you run?
I heard my
grab
dad
his
get
bag.
it.
How do you break your brace?
You are doing.
You'll do.
Alright, some of you guys, let's look at, some of you guys are getting stuck. Alright, so what you're doing is you need an x minus 2 for this first one. And you need a 3 for the second one. So that would give you x plus 3 times x minus 2 over 3 times x minus 2. And then over here you got 3 times 8 over 3 times x minus 2. And the order on these two don't matter. You could do x plus 3 times x minus 2, or you could do x minus 2 times x plus 3. And then you've got your denominators are the same, so you can cross those out, leaving you with x plus 3 times x minus 2 equals 24. Okay? This is where we're having some trouble, this x plus 3 times x minus 2. If you had me, I don't use the box very much. But you're doing x times x, which is x squared. You do x times negative 2, which is negative 2x. You do 3 times x, which is positive 3x. 3 times negative 2 is negative 6. This equals 24. Now, if you had Coach Brown, I think he uses the box a lot to multiply there. You got an x and a positive 3. You got an x and a negative 2. X times x is x squared. X times 3 is 3x. Here you get negative 2x. Here you get a negative 6. You can put those two right there together. You're going to get x squared plus 1x minus 6 equals 24. So you can do it either way. If maybe you were used to using the box, here's the place that you use the box. When you're multiplying those two things together in the parentheses, that's the box. So maybe that'll help if that was the case. Now, this one, like example 1, has an x squared. So since it has an x squared, what do we need to do? All to one side, right? So I'm going to subtract that 24. So x squared plus 1x minus 30 is going to equal 0. You'll move everything to one side so it is equal to 0. You are then going to factor, if it will factor, I think everything you see should factor. This will be an x. This will be an x. Negative 5 plus 6. So then the answers are going to be, you got x minus 5 equals 0, and x plus 6 equals 0. So you end up with a positive 5 and a negative 6. We forgot to do excluded values. What are the excluded values for this? Just a 2. So 2 is not 5 or negative 6, so these are both okay. So those will be our answers. Okay, Desmos, I always want us to check it on Desmos. You can just do it on Desmos if you must, but you won't make 100 on the test if you do that. But you could. So you got x plus 3 over 3, and the other side is y equals 8 over x minus 2. And you look for where they cross. So you got a 5 right there. Right here you got your negative 6. I realize it's hard to see with all my other stuff, but I don't want to make this go away. Okay, several of you got to that answer. That's very good because these are not easy to do. So several of you got to that answer on your own. That was very good. All right, we got a couple more that we're going to do. Is there just 2? Or have I got 4 more left? I might be selective on this. We might just do one of these and one of the ones on the next part. Because I want you guys to have time to do a little bit of work at least. All right. I got this one. I've got a 3, an N, and a 6. What do I want to use as my least common denominator? 6N. Okay? So, my first fraction has a 3. What do I need to multiply it by? A 2. And, I think I heard it somewhere. What else? And an N, because it does not have an N, so I'm going to multiply it by an N also. The second fraction has an N. What does it need? It needs a 6 right there. So 6 on top and bottom. And the last one has the 6. What does it need? N. All right, so I've got 8N over 6N minus 42 over 6N equals N, or 1N over 6N. What is our excluded value? N cannot equal 0. Because if I put a 0 right there, 6 times 0 would give me 0. There. All right, now, these match, so I can mark them out. That just leaves me with 8N minus 42 equals 1N. What should I do? I could move everything to one side. This one is not a quadratic, so I don't necessarily have to. I'm hearing people tell me to take away this 1N, which gives me a 7N minus 42 equals what? 0. All right, because nothing's left there. So I'll add the 42 now. So if 7N equals 42, divide by 7, and we get 6. Was that our excluded value? It was not, so it's okay as our answer. We're okay there? All right, I'm going to skip 5 so that you guys have a little time to work on your assignment in class. It's very similar to this one. Let's go to number 6. 6 is a little bit weird because what are we doing over here? Is this a fraction? It is not. Same thing on 7. It's not a fraction, right? So everything must be a fraction in order for you to do this and mark out denominators. So if you see something in a problem like this that's not a fraction, what you need to do immediately is put it over 1. Okay? Same thing, like we're not going to do 7 because we're running out of time, but we would put that over 1. And all the denominators have to be the same, including this one right here. Now, I've got c squared minus 4c, I've got c minus 4, and I've got just a 1. Will any of those factor? This first one right here, what can I pull out? A c. So this will factor, I'll still have my 3c minus 2. This could be c times c minus 4. And it is better to do that because right here you have a c minus 4 also. So that's going to make it better for our least common denominator. So for that one, what should my least common denominator be? So I see these two both have a c minus 4, right? So I definitely need a c minus 4. This one also has a c, which is a separate part. I must include that. This one has a 1. Do I need to include the 1? There's like an understood 1 there already. So I don't have to put the 1. If you wanted to, you could. It's not going to change anything. But I already have that 1 right there. Now, if that was like a 7 or something, I'd have to include a 7 over here. But just a 1, we don't have to write it. So this one already has everything it needs. I got c times c minus 4. Right? That already matches my least common denominator. What is this fraction missing? A c. So I'm going to put a c on the bottom and a c on the top. Okay? What is this fraction missing? Both things, right? I don't have the c or the c minus 4. So I've got to multiply by c times c minus 4 on top and bottom. Okay? So I have 3c minus 2 over c times c minus 4. I've got, what is c times c? C squared over c times c minus 4. You could distribute here, but be careful because there is a minus sign right there. And if you distribute, you're going to forget to take that minus with it. So let's just leave it like it is right now. Okay, so now all the denominators are the same. I can cross them out. Okay, so I've got 3c minus 2 equals c squared. You can distribute the c right here, but the minus has to go with it. So you are going to get minus c squared plus 4c. This one looks like it's a quadratic. Is it a quadratic? What would happen right here with c squared minus c squared? Those cancel out. So you do have squares, but they cancel each other out. So this one's actually not a quadratic. We've got 3c minus 2 equals 4c. How do I solve that? Minus the 3c. Negative 2 equals c, 1c, so I'm done. Negative 2. Is negative 2 okay? I forgot to do excluded values. Would it give me a 0? It would not, right? I just can't have a 4 or a 0 for this one, so that is okay as my answer. Yeah. Yes? What you want to do is you want to factor first, right? And then once it's factored, you're trying to think of like what could I multiply so they'd all be the same, right? This is your most complicated denominator. So you know you have to include everything there, right? So you want to take, basically you can take your most complicated one first. And then you can decide if you need to add anything to it. So the most complicated is c times c minus 4, right? I could make this one c times c minus 4 just by multiplying by the c on top and bottom. So I don't need to add anything to my least common denominator for that one. This one just has a 1, so I could multiply by C and C minus 4 on top and bottom for that one also. And so that would make all 3 of those match. So that is what I would use for that. Yes. So your restrictions are that why is it not writing? C cannot equal 4 and C cannot equal 0. And since neither one of those are answers to our problem, it's okay. It doesn't happen very often that they actually end up being answers to the problem, but let's say that -2 was one of the restricted values, then we would have to say there's no solution to this problem. We'd have to throw it out. You're taking the denominator, and neither piece of the denominator can equal 0 for that. So C cannot equal 0, and C minus 4 cannot equal 0, which means C cannot equal 4. Just the opposite sign for those. If you have like a greatest common factor sort of thing there, it's always going to be a 0. Unless that, like we didn't on the one where we just had a 3 out there, because 3 is never going to equal 0. But if it has a variable, if it has an X or a C, in this case, it's going to be 0. All right, questions? All right. I'm going to add Delta Math to your class-wise, so you should be able to get to Delta Math also, I believe. Okay, it should let you go to Delta Math also now. Okay, there's an assignment there. Let me look at my Delta Math. All right, it's 4.5 solving rational equations. Well, you only have to do 8. I would like for you to try to do them by hand. You're welcome to use your whiteboards. If you get desperate, if you're missing a lot of them, use Desmos. You can use Desmos to help you on these, okay?
Well, I didn't type in anything. It just showed up on the screen.
Mine will do it.
Yeah, it should have sent you there. Probably going to do deltamath.com. You just type in deltamath and try to search for it. So it should be on there. It won't log in. Alright, I'll cut off the focus for a second and I'll cut it back on. So you guys can get in. Alright, everybody get logged into Delta Math so it will let you log in with Google.